Hello, and welcome to another episode of Hacking with Friends. My name is Kody Kinsey. I am a security researcher at Varonis, and today we are joined by our very special guest star, Michael, our resident cryptozoologist. Michael, how is
You've
Bigfoot
used
doing
that
today?
one multiple times now.
I know. I think we should keep having you back to check in on the status of
exactly.
Bigfoot once a week at least.
Yeah, and then you can perform some Wi-Fi surgery for us.
Well, I would really just like to spin off a series where Michael talks about Bigfoot, and then anytime someone has any questions about crypto, I will refer them to my favorite cryptozoologist, Michael.
Mm-hmm.
I don't want to answer the questions myself. Well, today we have an episode that I think will be very applicable to just about everybody, provided that you've ever been in a plane or a hotel, because those two things have something in common that we'll be talking about today. Michael, do you know what it is?
Both have had Bigfoot.
Yes, exactly. Both have had confirmed sightings of Bigfoot, both from the air and also from the window of people's hotels.
Yes.
So that's what we're going to dive into today. How can we capture a clearer image of Bigfoot, but not so clear as to, ruin it for everyone?
Yeah.
But failing that, you're going to need to upload these photos. And if you're on a plane, odds are you're not going to have a good cell phone signal. So how would you manage to share these aerial photos you've managed to take of Bigfoot with the world?
Well, I could pay an exorbitant amount for Wi-Fi at the hotel or airplane.
That's
or
true.
A malicious individual could just gain access.
Or just a cheap individual could
Yes.
gain access. I mean, or maybe somebody with the best Bigfoot picture that the world needs to see doesn't want to pay $29.99 just to upload that one thing.
Yeah.
They just want to connect to the Wi-Fi in the plane or in the hotel room and tell everyone what they've seen.
Yeah, when you gotta upload those 8K images, we're well past those fuzzy, grainy, off in the distance shots. We need to upload massive files. So for massive files, you need a good Wi-Fi connection.
Michael's not going to get laughed out of his cryptozoology community with these potato quality images. The stuff he uploads is massive. So he needs a reliable Wi-Fi connection. How many times have you been on a plane or in a hotel, you see that there's a Wi-Fi connection available, you try to connect to it, and it's just like, ho-ho, like you need to pay us $49.99 for 1 hour or whatever, something stupid. And you get access to this very slow Wi-Fi connection that honestly should be free. But
and importantly, that's always on a landing page. So it lets you connect, but then as soon as you connect and try to go anywhere, it's popping up a landing page and saying, pay us.
Right. Now, this could be in a library. This could be pretty much anywhere. And you'll also see these sorts of systems in use, for example, like I said, at universities, where if you happen to know the password, then you can connect, but if you don't, then you can't. These are frequently used to keep people out while still allowing people to pay for use of access to the network. And this is interesting because it relies on some technology that we're going to be poking around at today. And spoiler alert, it is actually really easy to get around these and connect to a network that doesn't want you to connect to it. Now, we're talking about a very specific kind of networks today. These are like paid networks where, as Michael said, you can connect to them, but they don't allow you to actually get internet. They don't allow you to resolve DNS requests. You can't load websites until you put in a password or you pay someone. But the way that they actually keep track of devices is something that is very vulnerable. So if you're thinking of implementing a scheme that uses MAC addresses to decide who can and who can't connect to a network, then I think we're probably going to talk you out of that through the course of this live stream.
Yeah, and it's important to distinguish. There is like another kind of way you could do this, which is where you do have a legitimately normal website where users have to go there, sign up, and then they can take user credentials they have and use those user credentials to sign into a Wi-Fi network.
Oh yeah,
so this wouldn't work on that.
Yeah, well, yeah. So you're talking about like a Radius server?
Yeah, I'm talking about using WPA Enterprise with a Radius server.
Right. Well, one interesting point is that you can just go ahead and kick somebody off of their network. When they try to reconnect, if you like basically have them connect to a fake network or a man-in-the-middle network, you can pop them up a phishing page that gets their Radius credentials or it gets their credentials for airplane Wi-Fi or hotel Wi-Fi, and basically do a social engineering attack instead. So we're actually going to be attacking the technical mechanism that is trying to select which MAC addresses or which devices are allowed to connect. There's another way of doing this where we just like pretend to be the network and we're like, all right, buddy, I don't trust you anymore. You better give me your password because I don't know you.
This is
And-
a Bigfoot inspection point.
Exactly.
We need to provide credentials.
Exactly. And then they're just like, oh, I'm sorry, Mr. Router. Like, well, here's my credentials. I assure you I'm allowed here. And then the router's like, all right, just this one time. But that was actually me. And then I just take those credentials, kick them off the network, join, and then if they try to join, they're going to get like a duplicate IP address or like something like that, indicating that there's more than one person on the network. So this is a way that you can get around security when it comes to attempting to lock down networks by MAC address. And I think it's very funny because a lot of these places that I see Wi-Fi for sale really shouldn't be doing that, because it exposes their customers to attacks like this. Like, it allows other people to do bad stuff to the network. It's just like, it's better to set like a WPA and just give your customers the password at a certain point. But if you care more about money than you care about security, then this will work just fine, I guess.
Yeah, it's a good point why you shouldn't be a greedy bastard, essentially.
Yeah, pretty much. Yeah, I mean, you know, you start nickel and diming people too much over something that they like kind of need, and people will find ways around it. Now, this goes back to what we're gonna be looking at today, which is MAC address filtering. So MAC address filtering allows us to go into the router settings and set a certain logic when it comes to who is and is not allowed to connect to the network. Now, if you are new to networking, then every device, this computer, Michael's computer, my cell phone, all has a MAC address when it connects to a Wi-Fi network. It's kind of like the license plate on the device, where it stays usually stays the same, unless it's like a newer Android device, when it connects to different networks. And it might get a different IP address when it joins that network, but the MAC address will stay the same. That's why I compare it to a license plate. It's an identifier of the device that is more or less going to remain the same. But that's not always true. You can actually change your MAC address. Like my cell phone, for example, doesn't make it super easy for me to, but it is an option, and I can do that on my laptop very easily too. And that means that if I can change my license, the license plate of my car or my computer, like it was a car, then it makes it really difficult for the router to keep track of who is who if like those license plates are just swapping around. So what we're going to do is take a look at the mechanisms that network operators have at their disposal to limit your ability to connect to a network, and then look at our ability to mess that up really badly and get into the network anyway.
Yeah, and so why might a network operator choose to do MAC filtering? Because, like, in my mind, it seems like if the people aren't super technical, like, I mean, it's pretty easy to change your MAC address, but if they're not super technical, it can be a good way to be like, okay, you know, I want this device to not be able to access the network at all, or I don't want it to be able to access at like certain times of the day, or something like that.
So let me give you two scenarios. One, children. Let's say that your child is addicted to technology and is like getting like dangerously worse. And they have a device, and for whatever reason, it's difficult to take it away, or they might be able to get access to it anyway. Well, you could just, like Michael said, ban it from connecting to the network for certain periods of time, and basically limit the amount of time that that device can spend connected to the network. Another one would be a neighbor. Let's say that your neighbor's just like, "Hey, it's so nice to see you. Oh my God, so I'm trying to show you. I'm trying to show you this thing, but it's not. I'm sorry. Could I connect to the Wi-Fi?" And then they remember the password and they connect their smart TV to it. So let's say you run a network scan. And you're like, "I don't remember having a smart TV, but my neighbor that I just shared my password does." So if you wanted to kick your neighbor's smart TV off the network, like it's, you know, an IoT device isn't going to be able to like change its MAC address as easily as, you know, something like my computer. So if I wanted to kick my nosy neighbor who's got my password and is now connected their IoT devices off, I could blacklist their devices. So, or I could whitelist my device and set it to blacklist all other devices.
Yeah.
So we're going to be talking about whitelist and blacklist because they allow us to set the logic to whatever the use case might be. Again, somebody who has the password but shouldn't. A child that should only be connected via maybe certain times of the day. Maybe I just don't want any of my IoT devices to be exchanging data or connecting until I'm home. Like, so during the day, I just block them so that, you know, my smart TV can't even connect to the network at all. Therefore, nobody can mess with it or whatever.
Right.
You know, there's lots of reasons why I might want to control which devices connect to my network. But it's useful to think about the capabilities of that device. If it's a laptop, it's pretty easy to just change your MAC address. If it is an IoT device, maybe not so. So this is still somewhat of an effective mechanism for controlling access to your network, but there's lots of holes in it, and we're going to poke some of them today.
Right, and this is actually something that's available on most home routers. Like, so if you want to, I can go ahead and switch over to my screen. I think we're going to see your screen for a second.
Oh my gosh, please, this is private.
Okay.
I'm trying to log into my private account.
And then, so the first thing you can check is go to your default router page, which is usually 192.168.1.1 or like 10.0.0.1. But yeah, so like the first thing you can check is you can go to a page like this, the ARP list, which some of this is going to be blurred, but then you'll be able to see what's ARP stand for, Kody?
Address Resolution Protocol.
Yes. And so essentially what that is it's sort of like the phone book for translating between MAC addresses and IP addresses, or for the router. So that's an easy way to see like which devices are connected. But for a lot of these devices, you can go up to something like the wireless settings and then wireless MAC filtering. Yes. And here you can see, so this was disabled by default, so I had to enable it. It's a little confusing on TP-Link, because it's like, deny the stations specified by any enabled entries. So you would psychologically you would think these are all whitelisted, but in fact these are all the blacklist items.
Yeah. So the logic that is applied to this is like you need to be clear about what it is. Like a blacklist means that everything on it will not be able to connect to the network. A whitelist means that everything on it will be able to network, but ambiguously, depending on how your router works, that could mean that everything else cannot. So like you really need to be clear about these terms and what features you're turning on, because you might be like, oh, I'll just whitelist my phone just to make sure it can connect. But you might have actually just turned on a feature that blacklists everything that's not on the whitelist, which means that now nothing else will be able to connect to your network, and maybe all your roommates get really mad.
Yeah, that is something I would say you have to be careful about. You do need to be fairly methodical if you are going to be using this about what MAC address is corresponding to what devices. So that's where I might even recommend something like Fing or another network scanner, and then just have a little powwow with everyone in your household and be like, okay, this phone belongs to you, and then just make a little list if you were going to try. Because as much as we are showing the vulnerabilities of this approach, it is another layer of security. It's not going to really stop anyone that knows much about hacking, but it's going to prevent the people from, going for the low-hanging fruit.
Yes. So we're going to present two different scenarios today, and we've only tested one, so you'll be along for the ride on the second.
So I'm going to switch to your screen?
Yeah, sure. The first feature we're going to be testing out today is MAC address blacklisting. Yeah. So what we're going to do is we've already banned this computer. Let's say that this is our neighbor who, has our Wi-Fi password, and we're just like, buddy, like, get off. So Michael has actually gone ahead and banned my computer from the Wi-Fi network, which I will not stand for. So we're going to show how if your device is specifically blacklisted, how you can still join the network. Now, the second scenario, which is more likely and also leads to free internet, is going around a whitelist where only specific devices are allowed to join the network. Now, in this case, it's not any MAC address except mine that will work. It is a specific MAC address that is going to work. So what we need to do is like look around and scope out like the license plate of another device that's already allowed to connect to the network, and then, well, we just make our license plate match. And it confuses the network into thinking that we're someone who has already provided the password or paid or whatever else it is that we need to join the network. And for a lot of these public networks, this works really well and is a reliable way of getting around something that only allows a couple devices to connect that have already gone through some sort of process. Even for me, I just use this so I can skip login portals. So I'm just like, I don't want to click accept. So I'll just like copy the MAC address of someone who has already accepted the login portal at like the library or something, and then change my MAC address to that, and then boom, it thinks I've already agreed to all that stuff, so it just lets me right in.
So will that not cause issues on the network where 2 MAC addresses are associated with 2 different IPs?
One IP.
Or 1 IP?
Oh, yes.
Yeah, so what would happen in that situation if they were actively using the network and you're actively using the network?
To them or me?
To either.
To me, I get internet. To them,
they don't get internet.
There may be problems.
Okay.
So keep that in mind. Like by doing this, you are sliding in on someone else's space, and it creates network anomalies. I will say. So one network anomaly is you might get a notification that there's a duplicate IP address, or that there's a duplicate MAC address on this IP. Like sometimes you'll get a notification IP address already in use, but then like the internet will work anyway. So like I find that this tends to still allow. Well, this is what usually happens. The person who's using the internet will basically run into an issue where something's funky. So they'll disconnect and reconnect. They will end up being routed to a different access point that's like, they're all providing the same name, but they're basically like all kind of trying to find the best signal or like provide more signal. And then they'll just log in again and they will get a new session, even though you guys are still sharing the same, like you're sharing the same IP address sort of. So it creates like a network collision that shouldn't be able to deliver internet to both people, but I find like still sometimes does, to the point that like both people don't really mind.
Right.
But yes, this also can have an impact on other people on the network. So ethically, it is a little bit dubious to be kicking somebody else off the network, especially if they've paid for it in order to get access. But in an emergency where there's data you really have to get out there, like in the case of a cryptozoologist trying to change
when
society
I just cracked the case on where Bigfoot resides, I need to get that info out there.
Yes.
Now,
sometimes at the expense of other people and possibly the law.
Hey,
so just be aware that
they would pay for this info much more than they're paying the internet.
That's true. So just be aware that you need to, before you follow along with our examples, you need to check the local laws in your areas, because in some areas this is legal, in some areas it's not. And for some networks, this might be considered unauthorized access to a secure computer network. If the arguably like an open network with white and black listing is not really like the same as like a password protected network in the eyes of the law, but there are some cases where non-technical people could probably construe it to look that way. So just be aware that if you're going to be accessing a network that requires you to have credentials or something like that, and then you deliberately change your MAC address to allow you to access that network, people may not believe that's an accident. So
so wouldn't it be possible to be a little nicer? Because dissociation packets aren't there. There's packets sent out when people are like leaving the network. So would it be possible to just sit there and wait for someone to basically disconnect from the network and then just clone their MAC address and use that?
This presents difficulties because now you have a condition where there's 2 devices on the network with a stable connection to the access point that have the same MAC address. So as you send out disassociation packets, they are also addressed to you. So maintaining your own...
well, no, I'm not saying actively dissociating them. I'm saying just listening...
you mean waiting for somebody else to leave the network and then taking their place?
Yeah, exactly.
Oh, that's an interesting thought. So, yes, if somebody out there wanted to create an automated tool that basically looked for devices leaving a paid network and then just like take their space, basically like take their remaining
Take their
time.
parking spot, basically.
Yeah, that's actually brilliant. Probably a lot less illegal.
Yeah.
And actually, while you might need to wait a little bit, would be a pretty clever way of implementing
Well,
that.
and especially I'm thinking like at a busy airport, because airport Wi-Fi is notoriously like that. You could probably, or with an airplane in particular, you're sitting there as people are leaving the airplane. So you have, 200 people that are deboarding before you board the airplane.
Call it, okay, whoever writes this tool, call it Wi-Fi dumpster dive.
Yeah, okay.
Yeah, so very, very possible. I think that's probably the more ethical way of doing it than just like waiting until devices are leaving the network so you're not creating that conflict. So that's going to be my official endorsement. If you are going to try this technique, try to make sure that the other device gracefully leaves the network without doing that yourself. Don't kick them off the network. But if someone's leaving the area and, they've connected to the free Wi-Fi and they're not using it anymore, then this is something that would probably work without causing a network conflict for that person. Because that's really the part that is a little bit dubious on this, is causing network issues for somebody who,
and hopefully
hasn't done anything wrong aside from enabling this behavior of requiring people to pay.
And hopefully it's not bandwidth monitored where they charge you based on the amount of bandwidth you used.
Yeah, that's true. All right, so let's go ahead and take a look at what we got going on. We are trying to connect to a network called TP-Link, and it is not working. I know the password, but no matter what I do, when I try to connect, it just doesn't work. So, when my Wi-Fi devices are also disconnected. So I have a Linux computer. I'm going to go ifconfig, and I can see I don't even have a wireless card right now. It's down. So if you've ever had a case where you're in Kali Linux and your wireless card just vanishes or goes away, that's because bringing it up and bringing it down is its own thing. So if I do, I'm already root, so I'm not going to sudo it, but ifconfig WLAN 0, it's the name of my card, up. If I run my last command again, ifconfig, then boom, I should have my wireless card right here. Okay, so now I can scan again, and I can see that if I attempt to connect to, there we go, TP-Link, unless it's changed
probably
its
see
MAC
a lot
address.
of blurred stuff there.
Yeah, sorry. Unless it's changed my MAC address again. Let me. Oh, and can you go on your screen? Can you go to the router blacklist, please?
You mean, do you want me to show it on my?
Yes, please.
Okay.
I just want to compare. So the MAC address that my card is currently using is starts with 60 and ends with 92.
Yeah. So I will blur the center of those addresses. But yeah, so we have basically the original address, and then we have, for testing, changed it to this.
All right, so I can see that I've tried to connect to the network, but it's saying that the network is.
You want me to shoot?
Yeah, so I'm trying to connect to the network, but it's saying that the network is unreachable. I can't ping. And Linux is confused. It's like, you're connected, but I'm not connected. In fact, it's establishing a connection intermittently, but it can't actually draw down data. This is a problem. We're not actually able to get anything here. So what's the problem? Well, even though I have the credentials to this network, I don't have permission to actually get data. As soon as I hit the router, it's basically like applying a filter to me and saying, hey, you're on the blacklist. Everybody but you can connect to this network. And again, I could be a nosy neighbor.
It's a real friendly router, you know. It's like everyone gets awesome Wi-Fi except you. So.
Yeah, so I can't ping Google. I can't resolve stuff. I can't do anything. It sucks. So can I even scan?
Ooh, that would be interesting.
Oh yeah, it can't even figure it out. Okay, so this sucks. Like we can't do anything here. What is going on? Well, what's happening again is we're being filtered, and if we change our MAC address, then we can make all of this go away. So there's a very easy tool we can do to just change our MAC address from what it is now to a different one. And also, this is a privacy preserving tool if you don't want people knowing what kind of hardware you have, because your MAC address is set by your manufacturer to identify itself as being from that manufacturer. So if you were to randomize your MAC address, then suddenly people can't tell what device or what manufacturer your device is from anymore. So that's the difference between knowing that this is a ThinkPad and thinking it's like an iPad or some random other
Lockheed
device.
Martin
tactical networks device. Yeah. So if I type, let's see, is there a man page for this?
So point of order here. How do you know that you're not able to connect because of your MAC address versus you're just not able to connect because you don't know the right password?
So if you can't connect because you don't know the right password, it will come back and say wrong password.
Gotcha.
Or otherwise give you the option to put in a new password. If you're just being blacklisted, then you will either not be able to connect at all and it won't prompt you for a new password, or you'll be able to connect but you won't get any data or anything. All right, so this is Mac Changer. This is a Linux application. I think it's built into Kali Linux, but you can also just install it with apt install Mac Changer. It allows us to change the MAC address for network interfaces. So we can see that there's a bunch of options here, but really we just need to select the -R or random one. Or if we have a specific MAC address in mind, we can do -M. So the syntax here is really, really basic and mostly positional. So it's the syntax is Mac Changer then whatever options we want. So -R, for example, would be to randomize the MAC address, and then the device we're talking about. So in this case, WLAN0 is our network interface. Let's quit. So I want to change my network interface to be random. So I can do MAC changer, and I would need to sudo this if I wasn't already root. Oops. What?
What have you done?
I'm just pressing random button. I meant to do control +++. There you go. MAC changer -R for randomize, and then WLAN0. All right, so it has the current MAC, the permanent MAC, and then the new MAC. What does that mean? Well, you can see that the permanent MAC is an Intel corporate. So that means that, this is from Intel. We can tell that this is an Intel computer,
Okay.
Or at least an Intel wireless card.
Right.
So the new Mac is random. It is not assigned to any specific manufacturer. It is just, whatever. And what's interesting is I shouldn't have been able to do that.
Shouldn't have been able to do what?
I shouldn't have been able... Oh, right. My wireless card went down for no reason. So if you're doing this and it doesn't work, then if I type ifconfig, binet... no, I'll just do ifconfig.
I was going to say, don't give me a bunch of stuff
it's not
for
here. It's gone again. So this interface has gone down. And if I do ifconfig WLAN0 up, the wireless card is up now. If I try to change the MAC address again, could not change MAC. Interface up or insufficient permissions. Well, I'm root, so it's unlikely to be the second one.
So basically whenever it's in use?
Yeah, so whenever it's in use, then that creates a conflict and you're not able to change it. So right now, I'm going to, if I want to show the right thing to do, I can do ifconfig WLAN0 down. And there's another way to do this using IPA, which I should be showing because ifconfig is actually deprecated in some versions of Kali Linux, but you can install it with NetTools. But anyway.
I mean, this all does make sense. It's like trying to put gas in a car while it's running on the highway, right? Like, you kind of need to pull over and stop to put gas in.
It does interrupt like network connections. It causes a mess, like if you just try to transition it over. So the card is down now. It won't appear if I do ifconfig. I run MAC changer, boom, it'll give me a new random MAC address. Press Control L.
Is there a way to change the permanent address?
No.
Okay.
But there is a way to have it, as soon as it boots, assign a random one.
Gotcha.
So, or assign like whichever one you want. In fact, like you can make MAC changer part of your startup script so that it just sets it to like a predetermined one or one in a predetermined range. You could have some wacky like like generative system to like make a bunch of different devices and then keep changing it. It's all up to you. But that does create some like network weirdness sometimes. So now we have a new MAC address. So hopefully when I bring the card up, I should be able to scan around and see networks again and try to connect to one. And what I'm hoping is that I'll be able to connect to this network that was previously not allowing me to connect properly. Let's see if that is the case. So I'm going to try pinging 1111.
This episode is going to be so much blur for y'all. I apologize preemptively for that.
And this is where, all right, we're connected, but now our card has gone down again. This is a Kali Linux issue that I've been having, which is unfortunate. And I might need to use a second card in order to get around it. Because right now, the only other thing I could do is just like literally a restart.
Yeah, which is... Oh my god. Yeah.
Yeah, well... I mean, so according to Kali Linux, I am connected. According to this little icon, it's still thinking about it. But, yeah, we're getting the same failure in name resolution. So I'm going to plug us in a second wireless card. And we might need to ban this one too, but I think it might... There's two options here. Either Kali Linux itself is unstable, and the program that's running the wireless card is
out of date?
Freaking out. Well, no, I've updated it recently. Or something else. So I'm going to connect to this. I'm going to type in the password. And we're going to select the RA link. Hey.
Which, of course, erases the password.
Yeah.
Because reasons.
And let's see. All right, so maybe we'll have to ban this and then show you how to do MAC changer on a second one. But whatever, the concept is the same.
Well, right
regardless
now you've randomized the MAC address, so you should be able to connect.
Yeah, of
Yes.
course. All right, so right now I'm able to connect, but again, I'm using the second card. So if I do IPA, oh my god, that's horrible looking. Then I have WLAN 0, WLAN 1, and WLAN 1 is the one that can successfully connect right now. So, all right, let's kick off our second example just so that we don't run out of time doing this. And let's say that we need to do a blacklist. So right now, Michael...
Currently, I'm blacklisting 2 MAC addresses for that system.
So we I think need to switch over to a whitelist.
That's going to be
So we
little
should-
more difficult because I'm connected via Wi-Fi.
Yeah, so I think you're going to need to open 2 pages, one with the current devices that are connected, and a second one with the whitelist, and then add each one.
A bit, yes. Switching over to mine. So basically what I think I would have to do is allow the station specified by any enabled. So that would be the whitelist. So then it would have yours whitelisted, but then I need to whitelist this computer.
Right, so first disable the blacklist, and then add your other devices to this list, and then enable the whitelist. So this is the process of, let's say that you're at a hotel. You connect, you pay.
Okay, I'm going to switch. Can you clear that screen, please?
Yeah, sure. You connect, you pay, you get assigned basically a ticket that says this MAC address is allowed, and there you go. So for this device, I'm going to
Okay, so
see. Basically just try Mac Changer and make sure it still works. Oh, I have to take it down first. Mac Changer -R WLAN 1.
yeah. So I don't know which how can I tell which MAC address this computer has?
Well, just copy all the ones that are connected one by one. Right?
That's going to be a very time-consuming process.
There's 5.
Yeah, but I have to type them all in manually because it won't let me copy and paste, which is unfortunate.
Yep.
And then also, so does that have 5 gigahertz?
Yes.
Can you do that? Will solve our problems. So one interesting feature of these routers is it allows me to do MAC address filtering based on whether it's 2.4 or 5 gigahertz.
Mm-hmm.
So how about I do a whitelist? So can you give me the MAC address that you're using that
Yes.
you want me to whitelist? Okay, so add new. Okay.
Wait, why are you whitelisting this?
You wanted me to whitelist your computer, right?
No. So there's 2 conditions.
What do I need to whitelist?
All right. So to demonstrate the whitelist, you need to whitelist another device on that network. So if that's your computer, that's great. I guess if you need to, I can connect a second one here.
Yeah.
But the point is that there's a device that is allowed on the network already, and I need to copy its MAC address in order to connect. So let me connect with this, which is emulating like some
Yeah, or I
random...
can use on my phone.
That's what I just did. So now it should be connected. There we go. It's connected on 5 gigahertz.
I still need to see the MAC address, if possible. Because unfortunately, this is where
Here's the MAC address, but you could just refresh that page of devices that are connected.
Yeah, okay. Yeah, sorry, I can't show you this on the router because then I would have to blur everything, so...
Right.
But yeah, it's a pretty easy process, even if some routers are less elegant. If you do want a more elegant system for this sort of thing, you can look into our previous video on pfSense, which would allow you to do this a little more easily. Okay. Okay, and then... Okay, so that cellular device is now whitelisted, and everything else is prevented from accessing the 5G network, in theory.
Okay. So, right now, if I want to use this wireless card and connect to the 5 gigahertz network, I can select it here.
Yep, and it just kicked my cellular device off the network. So it is indeed in effect.
All right, so if I try to connect, it's trying, and it should not be able to.
Mm-hmm.
And hopefully now that I'm not using the internal card, it's not just going to freak out on any network. So again, we're simulating the condition of a hotel network, airport network, something like that.
And then you could emulate the MAC address of your cellular device to show how easy it is to actually be able to connect.
Well, all right, it's it's connected to the 2.4 gigahertz network because it can't connect to the 5 gigahertz one. Okay, cool.
Yeah.
So that is really interesting. And what I want to do, let me see if I can do this. So what we need to do is basically, in that brief moment that we connect to the 5 gigahertz network, we need to try to scan or otherwise find the MAC address of a device that is allowed to connect to the network. So sometimes I'll just connect and go to the page, and I will just start listening in on traffic with TCP dump or Wireshark or something like that.
Can you clear the screen, please? Because they're not going to be able. Yeah, thank you.
Well, now it's an empty screen.
Yeah.
It's not really much of an improvement.
No, I mean, that's better. Because I'm having to blur all these MAC addresses and all the Wi-Fi names. So, yeah.
Great. Okay, so what we need to do in order to connect to this network then is determine who is already connected to it. And this is something that we can do in a couple of different ways. We can do this in Wireshark. We can do this pretty much any way we want to. But the trick here is also making sure that Wireshark is scanning in the right frequency. So I'm not sure if it's going to do that gracefully. Let's give it a try.
Oh, so you're trying to show how to scan for networks?
Well, no, I'm not trying to show how to scan for networks. What I'm trying to do is show what it looks like to be able to find another device on the network that you're interested in. So, for example, if you want to, I guess we could just do, on the internal card, airmon ng starts WLAN 0. So this will bring up the internal card to start scanning, and then we can do, if you want some more stuff to blur, aero
This is already a nightmare
ng
episode for me.
WLAN 1 mon. Oh, man, arrow dump ng. So here, if we're looking at channels to scan on, one thing that's interesting is if we want to scan on 5 gigahertz, we actually have to do some random other thing at the end here. So these different programs are capable of working with newer wireless network adapters that, for example, scan in 5 gigahertz. But off the top of my head, I totally forget what it is, so I have to go and look. Oh my god, there's so many different things.
Yeah.
Channel. Beacon packets, maximum speed. Yeah, so, oh man. Scanning on 5 gigahertz is frankly a pain, and that's why I hate that we're doing it now.
We could gloss over that for now, because we are rapidly running out of time. All right. So, yes, typically what we would do is, for example, listen in on a particular channel and try to identify whether or not we can find a device that's already connected. Now, currently, we are scanning on channel 10, and because Michael has put us on 5 gigahertz, I would need to run some other argument to make this actually scan on the correct channel. But assuming that we already know the MAC address of another device, which I will take here, what we're going to do is try to bring up our second wireless card and change it to a different MAC address. So this is one that we can show because it's nothing. Okay. So I'm going to bring down the wireless card that is currently trying to connect to the 5 gigahertz network. I'm going to, now that it's down, I'm going to run the MAC changer command, but this time I'm going to change it. Instead of -R, I need to make it -M,
because I'm picking a specific MAC address. And then BA 3. Oh my god.
And you said we can show this one.
Yes, that is what I said.
Okay.
Because we can. 5E.
So do
Please don't talk to me while I'm putting in this MAC address. EF. Okay. So what this is going to do is hopefully, if it accepts it, then my new MAC address is going to be this one that I just typed in. And this is the randomized MAC address of my cell phone. I have a feature on this newer Android phone that allows me to select just some random network, some random MAC address when I connect.
Yeah, so that's what I was going to ask. So is it common for devices to randomly generate MAC addresses?
For newer Android devices, yes, and increasingly mobile devices will do this to try to increase your privacy and security.
Gotcha.
So I'm going to bring this back up, and now my WLAN 1 card should have a brand new MAC address, and theoretically, I should be able to connect to this. Although with the way that the stream is going, who knows? So let's see. I'm hoping, yep, all right, it comes back up. I can select the 5 gigahertz network. It'll ask me for a password. And then it's going to check us and see if we are on the list of devices that is allowed to connect. And of course, my cell phone is already there, but with any luck, we'll be able to join anyway. Again, not much luck today, but let's wait and see if it's able to connect.
What if you disconnect your phone?
Well, I don't want to, let's see. Failed. What part of this also is my network card, or like the program controlling network card, is very unstable today. So some of this might also be, wait, what is this trying to connect with? WLAN 1? It didn't, sorry, I'm a little confused because it didn't give me more than one option to connect. It just assumed I wanted to do it with this one. Okay, it says I'm connected, but I don't trust it. It still says it's unreachable. And also my my Panda wireless card isn't blinking, which makes me think it's not doing anything.
2 eyes in the command. Yeah, maybe it's because Wireshark's using it.
Oops, yeah. Okay, so both of them are up. I have WLAN 1. This one has its spoofed MAC address. That's great. So what's up? Why are you not connecting 5 gigahertz? Are you sad? This is, at this point, this is just a networking issue because it shouldn't have an issue with that. Yep, everything looks fine, but it doesn't have an IP address, so it's not correctly associating. There's a little bit, so, okay, so now it's saying that we're connected to the 5 gigahertz network. It seems very proud of itself, and then boom, the wireless card just turns itself off. So I think I'm actually having an issue with my wireless card in Kali Linux, rather than this actually not working, because I will say this does work for me when I try it out.
Do you
in the
need
field.
to be using Linux? Could you do this on like a Mac or Windows machine?
Only if it uses Linux-like tools. I'm not sure about changing your MAC address on a Windows thing. I'm sure it's through some horrible menu. I'm just gonna turn this, like, take it down and bring it up again. But on a Mac OS computer, you can do this somewhat reliably, but I find that it frequently will just, like, it'll take you several times of doing the exact same thing to actually make it work. Why? I have no idea. So, yeah, I would say bringing this card up and down, and honestly, this worked for me after I restarted it last time, which I'm not going to do on the stream, is the procedure that's necessary to get around these white and black lists. In this case, we're trying to connect with a spoofed MAC address card, but I don't see this card doing anything. So I'm pretty sure that the program in Kali Linux that's controlling the wireless network adapter is just like messing up here and not really establishing a network connection, which is pretty annoying.
So I can switch away from your screen then?
Well, hold on. I'm going to unplug this.
Do we want to give it one last try?
And so, oh, well, of course I want to give it one last try.
Every time you open that menu, like a little piece of me dies.
Well, there's nothing being shown. Okay. So if I try to connect, I just want to see like a pulse. Like, did these switch where like this is the one that's now WLAN 1? I'm just so deeply confused about like why suddenly this wireless card is a pariah to my computer and like it won't interact with it. Like why? Like this card's great. Like and it has a little blinky LED to like show me when it's working, when it's not. So I know the computer's lying to me right now.
Yeah, and so for anyone that wants to get a network card, which ones would you recommend?
I do not recommend the PAU07. This is the card that has ruined my stream today, and I mean, realistically though, like I'm running an older version of Kali Linux, like that I've been running forever. So networking issues have started to crop up, and it's probably not specifically this card's fault, but I do blame it. I blame it exclusively for what's happened today. So yeah, that's too bad. Airmon ng stop wlan 0 mon. Doesn't do anything. Yeah, so like basically Kali Linux has just stopped managing this card. But I imagine that if you were to try this in Ubuntu with a lot of sudoing anyway, you would be able to accomplish basically the same thing.
Right.
So the drawback to this technique is networking issues. If you are looking to mess up your network connection, there are certain MAC addresses you can set your card to that make it unable to connect. There's all sorts of things you can do that make it not work. So while this is a workaround hackery method of getting around MAC address filtering, as you can see today, there's lots of things that can also cause it to go wrong.
So in the general procedure though, that a hacker would go through is they would scan the network to see which devices are connected, or otherwise find a MAC address of a device who recently disconnected from the network, and then they would use MAC Changer to then change to that exact same MAC address and then attempt to connect to the network. And in theory, that should succeed.
In theory, yes, that should succeed. Now, there are some other things that you can keep track of for a device that might allow you to determine that it wasn't who maybe it was saying it was. But this gets into some sorts of detections that tend to be more expensive, and most businesses that are charging for Wi-Fi don't bother to employ. But yes, there's lots of things that can go wrong. On your end, there's things that can go wrong on networking fronts, as you've seen. And then on the other end, there can be other defenses in place that make it more difficult for you to get access to the internet when normally you would need to have the password or something like that.
Do you have any examples of what those other defenses are off the top of your head?
No.
Okay. But yeah, so very useful stuff. Yeah.
All right. Thanks, Michael.
I don't know how to transition out.
Great. Well, that's all we have for today. Oh, look at this. My stupid Wi-Fi card is now turned on and blinking blue. Like it wants me... No, absolutely.
No.
I cannot be any more equivalent. No, like do not switch over to my screen because we're done with this. But thanks, Panda Wireless, for your wonderful wireless card. It went so well for us today, and I can't wait to use your brand again. We'll be using an Alpha wireless card in the next episode and seeing how that goes, because those people are nicer to us anyway. But yeah, it seems like this wireless card that's late to the party is now eager to connect to the Wi-Fi network and exchange data, and this is a good way for you to test whether or not your defenses can actually stand up to someone who knows a little bit about hacking.
Right.
So that's all we have for today. If you like this, make sure to also check out the Varonis brand content, because our sometimes co-host Killian is hosting the threat update over there with some really great updates. And also make sure to sign up on the hackingwithfriends.com website, where we will send you guys alerts when we're doing anything really cool and exciting. And also we give away prizes to random people who sign up for our email alerts. So yeah, that's all we got for today. We'll see you guys next time. And thanks for sticking with us. This was a rough one. Bye.